Hello guys, welcome back to my channel and we were discussing generating functions. This is part 3 of the series. If you haven't watched the first two parts, you can check out in the I tab, the discrete mathematics playlist. It's there in the playlist. Go check out those videos first and then come back to this one. Okay, so today we are going to see a very interesting set of problems that can be solved using generating functions. And there are two ways to solving this kind of problems. But there are special conditions or constraints where it is easier to find or count the number of solutions using generating functions than the standard bar and stars method. Okay, so let us see the questions. Okay, so you have three kind of balls: red balls, blue balls and green balls, and you can pick as many you like balls, red balls or blue balls or green balls, but the condition is in how many ways can you pick seven balls. You have to pick seven balls, and you can where the number of red balls can be greater than equal to 0, the blue balls can be greater than equal to 0, the green balls can be greater than equal to 0. So this is the question, that how many solutions are there, integer solutions, for red, blue plus green. They total make a sum of 7. Okay, and this is the constraint. You can pick 0 red balls as well, the balls can be 0 as well. So using the bars and stars method, how these type of problems are solved is, what you can do, you have seven things: one, two, three, four, five, six, seven, and to partition these in two groups, we need two sticks, right? We have three groups over here: red group, blue group, and green group, and to separate three groups, we need two bars, right? We will introduce two bars. Okay. So this bars represent this side of the bar represent that we have these two balls are red, two red balls. The middle part represents how many blue balls, two blue balls, and remaining you select the green balls. Okay. Similarly, another possible partition can be 3, 4, 5, 6, 7. This is also a valid partition. That means all 7 balls are blue in color. We have 0 red balls. These are the red. We have all 7 blue balls and 0 green balls. So how many possible solutions exist to this question using bars and star method? So how do we do it? To total how many places we have? 7 stones and 2 vertical bars. Okay. So that means out of 9 positions, okay, we have total, we will go to the next page. Total 9 blank spaces: 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that is 7 balls plus the sticks to separate it into 3 groups, 2 sticks. Okay, now you pick any 2 positions to place the sticks. Okay, out of 9 positions, I pick any 2 positions to place the 2 sticks. So its general formula is nothing but n plus r minus 1, choose r minus 1. Where r minus 1 are, if you have to make 3 groups, 3 partitions, then there will be r minus 1 sticks. N are the number of balls. Okay, so balls plus partitions, for making the partitions r minus 1 sticks, and you choose r minus 1 places from this to place the sticks. That is the general formula. Now this same question can be solved using generating functions as well. So how can we do that? Let's see. Okay. So before that, I want to let's prove uh, the generating function. Okay, the coefficient which generating function generates this this bars and stars formula. Okay, so what we will do, we will start with the expansion of a binomial expansion of 1 plus x power n. Okay, I know the coefficient of this generates the sequence n choose 0 x power 0 plus n choose 1 x power 1 plus n choose 2 x power 2 plus so on. The general term, rth term is n choose r x power r, right? Plus so on, plus n choose n x power n, right? This is the expansion, binomial expansion, or the sequence, the generating function for the sequence of n choose 0, n choose 1, so on till n choose n. Okay, now what we do, we substitute x with minus x over here. Okay, so let us substitute x with minus x. 1 minus x की power n, that is equal to n choose 0. Now minus 1 into x power 0 is 1 only, right? X power 0 plus, but here minus sign will be coming. Minus x power 1 is minus 1. So this would be minus n choose 1 x power 1 plus n choose 2 x power 2 plus so on. The general rth term would become minus 1 power r n choose r x power r plus based on the power of n, right? Whether it is odd or even, we will get minus 1 power n, n choose n x की power n, correct? Now what we will do is, we will substitute n by minus n. Okay, just bear with me why we are doing this. Okay, we will get the generating sequence for the bars and stars method formula. Okay, the generating function that generates that formula. Okay, so what we will do is, so let's move on the next page. Okay, 1 minus x power minus n is equal to n choose 0. So n choose 0 is nothing but 1. I can write it as 1 x power 0 plus, this was a minus sign, right? So that would be minus n choose 1, right? N choose 1 x power 1, and this n is substituted by minus n. And n choose 1, how can you write n choose 1? That is equal to, n choose 1 is nothing but n, and we are substituting n with minus n, so this would be minus n x की power 1 plus, right? N choose 2 is n into n minus 1 by 2, and this n will be substituted by minus n, so that would be uh, minus n into minus n minus 1 by 2 x power 2, then minus, and uh, n choose 3, that can be written as minus n into minus n minus 1 minus n minus 2 by 3 factorial, 3 into 2 x की power 3 plus so on. For the rth term, it would become minus 1 power r. Okay, uh, n choose r, how can you write it as r consecutive decreasing numbers starting from n? So that would be minus n minus 1 minus n minus 2, so on till where we have to stop. We have started from n minus 0, so we will end at r minus 1, right? So that would be so on into minus n minus r minus 1, right? Minus r plus 1. Okay, by r factorial, right? X की power r plus n choose n is nothing but 1. So I can write it minus 1 की power n. N choose n, x की power n. Right. All right. Now, what we can see, this minus, this cancel out and become 1, right? All the odd powers of x. And the even powers also, see, we can take out minus 1 common, right? Minus 1 from here and minus 1 from here. So what this becomes? 1 minus x e power minus n is equal to 1 plus nx plus this minus and this minus we are taking out, so it becomes n into n plus 1 by 2x square. And see over here also, this is x power 3, we have product of 3 terms, so it is a negative sign, but outside also we have a negative sign, so it becomes positive n into n plus 1 into n plus 2 by uh, 3 factorial I will write. Okay, 3 factorial x power 3 plus so on. The rth term would become, see here we have minus 1 power r, and how many terms are being multiplied over here? It was n choose r. So r terms, so this become minus 1 power 2r. Minus 1 power 2r. Right? So this becomes a plus 1. No, plus 1. So I am removing it. So it becomes n into n plus 1 into n plus 2 so on into n plus r minus 1 by r factorial x power r. Okay. 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 Fine. Plus so on plus minus 1 की power n x की power n. Okay. So yeah. So how can we write this general term? Can we write it like this? You have how many terms over here? The largest number is n plus r minus 1, right? And we are subtracting 1 and reaching n minus 0. From 0, we have r plus 1 terms, right? R plus 1 term. From 0 to r plus 1 term. So how many terms are there over here? Sorry, it is yeah, minus uh, minus minus r plus 1, right? Minus r plus 1. Okay, r minus 1. Sorry, it is r minus 1 terms, right? Yeah, we are adding 1 to, yeah, r minus 1. Sorry, from 0 to r minus 1. R minus 1. How many terms we have over here? We have R terms, है ना? So what does this become? This become the general term. The general term becomes n plus r minus 1. Choose r minus 1. Yes? Yes? So into x power r. So the generating generating function for this general term is 1 minus x, 1 by 1, yeah, this is 1 by 1 minus x e power n, right? So this is the generating function for terms similar to this. Okay. So for our question in the beginning, this question, how do we write the generating function for this? Okay. So first ball has how many options? X power 0, the red balls. It can be 0 red balls, 1 red ball, 2 red ball, 3 red balls, so on, plus 7 red balls, right? Similar for blue and green, so this we can write power 3, and we need the coefficient of x power 7 in this expansion. That will give us the number of ways we can do it. And I can, as we know that if I take one, if I convert this one more x power, like if I write it plus x power 8 plus x power 9, so x power 8 can never contribute to coefficient of x power 7. So I can write it as coefficient of x power 7 in 1 plus x square plus x cube plus so on plus uh, plus so on the infinite series x ki power 7 plus x ki power 8 plus so on. I can write this like this, power 3. Because x power 8 balls cannot contribute to coefficient of 7 ever. That's why we can write it like this. So this becomes sum of GP, infinite GP, that is 1 by 1 minus x power 3. That is nothing but this generating function which we saw in the formula. And what will be the coefficient of x power 7 in this expansion? We can use this uh, formula right here for now. What is n? N is 3. What is r? R is 7. Minus 1, choose r minus 1. That is 7 minus 1, 6. That is nothing but 10 minus 1, 9, choose 6, which is same as 9, choose 4. Okay. 9, choose 7. Oh, sorry. I have made a small mistake over here. See, in the proof where we did wrong. See, we had how many terms? We had from 0 to r minus 1. Total r terms we had, right? So this is n plus r minus 1. Choose r, not r minus 1. It would be choose r. So this is the reason. Okay. N plus r minus 1, choose r. So that would be 3 plus 7 minus 1, choose 7. Okay, this would be 7. This would be 2, right? We are getting the same answer over here. See, we are getting the same answer. Okay. And here note, this R is different. This R is how many partitions we have to make. This R value is 3, right? So R minus 1 becomes 2. And this R minus 1 is representing how many sticks. But here be careful. This R is representing number of balls and not the sticks. Okay. That's why this formula is looking different. This R is representing number of items to be selected and not the sticks. Okay. So yeah. Now we can see the question. This question was an example which can be solved using both the stars and sticks method as well as the generating function method. So you might ask this question, if we have such a simple intuitive stars and stick methods, then why to use this complicated generating function? Because there are more questions like this where you have to find the integer solutions for r, g, b equals to 10 with certain constraints. When constraints are included where red can be having value from 2 to 5, green can be having a value from 1 to green from 3 to 6, from 3 to 6, and the blue can be having a value from 1 to 4. So this type of problems we cannot solve using the sticks and bars method. Okay, here we have to use the generating function method. So how can we solve this? Red can take only values from x power 2 plus, this power is representing how many red balls you have chosen. Okay, or it can be r power 3 or r power 4 or x power 5. The green can be having from 3, x power 3 green balls, 3 green balls, 4 green balls, 5 green balls, 6 green balls, and the third will be 1 blue ball, 2 blue ball, 3 blue ball, 4 blue ball. Now what we need? We need coefficient of x power 10, because power is representing how many balls you have selected in this. Okay, so how do we proceed? Okay, what we can do, you can just multiply and see what is the coefficient of x power 10. Suppose we pick two red balls. Okay, we pick this term. Then how many more balls we need? 8 to make x power 10. So 8, how many ways we can pick 8? So we can pick, if we pick 3, right? 3 and 5 is 8, but we don't have 5 over here, so we cannot pick 3. So next is 4. If we pick x power 4 from the green balls, then 4 plus 4, then we have to take 4 blue balls. So one solution is this, right? Plus, if we pick 5 balls, then we need 3 blue balls, right? So we have another solution from here. And if we pick 6 uh, blue green balls, then we have 6 plus 2, right? Which is also possible 1. So this x ki power 10 plus more solutions. If we pick 3 red balls, then we need 7 more balls from the 2 other categories. So 4 plus 3 can make 7, one possible way. 4 plus 3, again one other possible way. 5 plus 2, so third way. 6 plus 1, so total 1, 2, 3, 4. 4 possible ways when 3 red balls are picked. When 4 red balls are picked, how many more we need? 4 red balls we have already picked from over here. So we need 6 more from the other 2 categories, right? So 3 plus 3 is 6. So we have one possible way. 4 plus 2, another possible ways. 5, 6, right? 5 plus 1, one other possible. We cannot choose 0 blue balls, so 6 and 0 is not a valid solution. And last, if we pick 5 red balls, then we need 5 more balls of other 2 categories, so we can make 3 plus 2 5, so that is one possible way. 4 plus 1 5, yeah. 5 and 0, no, 5 and 0 is not a valid solution, so only 2 possible ways. So total how much is coming the answer? 3 to the 6 plus 4, 10, 12 possible ways. So answer is coming down to be 12. So hope you like this video. Please subscribe to my channel and share it with your friends, and give your feedback in the comment section below. And keep exploring how in real world you can find generating functions, you can count or use generating functions. And happy learning. Bye bye.